So where I wanted to kick off with is really there's a real reluctance from contractors to do modelling. A lot of it is taking models from, architects, engineers, that sort of thing, and put them in Navisworks and all that. But one of the issues with that approach is it really only looks at the model as a final product, and it assumes, the means and methods and everything like that have been taken into account. So what I wanted to show is a number of workflows that we've been helping contractors with across the globe, with a real focus on how to automate these things, how to get the best capabilities there. Because a lot of the times, contractors don't have really senior modelers; they don't have experienced guys in terms of the Revit or ArchiCAD, whatever software, but they do know a lot about temporary works, they do know a lot about plant, they do know a lot about site safety, which is where designers typically lack. So you get this real disconnect where you get these guys who are great at Revit who can't actually create these environments that work from a constructability point of view. The other thing is the risk. Every time you sort of talk about this with a contractor, they're like, well, why would I do that? I'm taking on extra risk. As soon as I'm modeling something, it's risk. The reality is anything that happens on site with the contractor is their fault anyway. They're screwed. Doesn't matter who stuffs up in the supply chain. They're ultimately responsible for that. And sure, they can go chase the money down the line or whatever, but it's still holding up them and it's still holding up the project. So some of these points where they're like, oh, well, I don't want to be responsible, they still get screwed for it, basically. And then the models for clients, the FM piece where, they're like, oh, well, these things aren't important. Permanent formwork is obviously a critical part, depending on the type of project, can form a very critical part of the FM model as well, especially if you start winding services and things like that with mass concrete and other permanent structures. And then the other part is, well, it's an architect's and engineer's game, and we don't need to be worried about that. So as I said, they do not represent the means and methods, and that's one of the clear things that usually early on when a contractor's starting to put these models together, they're having to validate that for the client all the time. This is how we're going to build it. We're going to use precast. Why using precast? This reason, that reason. So all of a sudden, contractors have very similar discussions with the client that an architect has with the client. Why are you doing that? Is it more money? Go get this. Go get a price for that. And so these things end up in the forms of work method statements. Who's ever read those lovely things? 1,000 pages, 1,000 words, and you get through and you're like, I don't know what the hell that's talking about. What does this method mean? So on and so on. And they don't represent the stages. You're always looking at a project fully fitted out. That's not how it works. So starting off, this is some work we're doing in Paris. With our bad monkey, Julian. So starting with the simple things, showing how we're going to do the edge protection around these lift cores, showing how we're going to set this stuff up, how we're going to do the jacking analysis, and even holding the permanent formwork in there while we get the top-down construction done. These type of work and these type of imagery isn't just about, okay, here's a pretty picture. These actually form part of the contract documentation, and same with things like, temporary work, site logistics. So very clear indication of how we're getting into site. In this particular site, it's very close to the water table line. So the reason this is quite a small little footprint, but the reason the sequence is so complex is because there was a lot of flooding that was going on with the site. There had to be a lot of sheet piling put in to waterproof it just to make sure that the various areas of the concrete could dry so we could get the basement in. So these type of analysis suddenly become really, really important. And originally this was done as a work method statement, and the reason we ended up helping him out is because no one could understand what the guy who wrote the work method statement was talking about. They kept reading it and they're like, I don't get what's going on. So these make it very, very simple, but then you get all the initial extra stuff out of it too by modeling it properly. You get the quantities. You know exactly how much dirt we're moving every single stage. We know how much concrete we're putting in at every single stage. So these work methodologies become really, really important. Again, with formwork, people would be like, oh, well, why would you model formwork? In this particular project, we got the drawings back from a Korean formworking manufacturer, and they were horrible. I don't know if anyone's seen like automated formworking drawings. They're a freaking mess, and that's a nice way of putting it. We went and modeled it because we were like, okay, this thing seems to have a few problems. And we found that over 85% of the formwork was custom components. So because they just ship their normal drawings, so we spent 2 weeks refixing it, and we dropped the price, we dropped the custom componentry down to about 15%, so using their standard products, and we pulled about $3 million just out of the formwork on 4 towers. This bottom one was also interesting because I think this is the original 2D jacking sequence, and what happened was the crane was put in a location in CAD, and because this tower winds in and out, so what happened is as the crane jacking gets further away from the cores, all of a sudden they didn't realize because the foundation's gone in, we're having to put these big precast beams to connect the crane back in. So again, probably 4 or 5 meters to the left for all, I think it was 5 tower cranes. I'll bring up the job. But again, we lost like 500 grand putting this stuff in, having all these precast beams because someone was just looking at a 2D flat plan and not doing their analysis correctly. Don't worry about that. It's just a 4D of a crane. But again, this type of simulation, so this is a 52 clear meter span with a swimming pool. So we analyzed 3 different ways, but showing this to the owners, we had a precast option and in situ option. We ended up going the precast with a steel foundation. Just really communicated, the approach that we wanted to take, the approach that they thought was best, and we were able to achieve that very easily. Another one that's a bit more on the automation side, this is a rail job that we're helping out in Malaysia. It's about 200 kilometers. There's 289 culverts. The engineer had a spreadsheet of 289 of these, and we're able to use Dynamo computational design. A couple of people familiar? Yep. Basically, it's a bunch of tools that allow you to generate models on the fly. Is a really simple way of explaining it. But we were able to generate all these different culvert configurations by reading the alignment. It was then able to take the calculation, set a perpendicular, read the terrain points, and then generate all 289 of these culverts in the positions they needed to be along the alignment. Super detailed equipment. I don't know if anyone knows Marcelo. He works with us out of LA. People go, why the hell would you model something that sophisticated? That's ridiculous. These joints are all properly configured to the manufacturing spec, which means they all have embedded inverse kinetics. And what that means is it works like your arm. It can only be pulled and pushed within the constraints of that physical equipment. So what happens is, again, in the native authoring environment, if a guy wanted to go in and just confirm that the scissor lift could reach that point, they could drop that component in, drag the arm, and it will physically stop at that point. So they know, okay, what does it look like deployed? Will it fit in the space? Can I actually go and reach all those areas by dragging? And all of a sudden, a technical guy with 10 minutes can perform things where they, just leave it till later, and then, there's no room, which is always a big issue with equipment and plant. So, processes. Can't stress this enough. Anytime you implement any of these new processes, and we'll go through some of the existing ones, some of the automation stuff as well, just check. I think a lot of the problems in the last 10 years that we've got is people have kept adding things on top. And so we get more and more of this, we're doing BIM now, but keep giving us a PDFs. We're doing clash detection now, but make sure your guy the old engineer is looking over it on his drawings as well. So all of a sudden we've got 2 people doing clashes, and we've got guys doing BIM and guys doing drawings and this and that. And so we get this real friction now with I guess, internally and dealing with government organizations where you get top level going, BIM, BIM, BIM. You go talk to the technical engineer, he's like, mate, give me the drawings. And so this disconnect does cause a lot of friction. So anytime, especially internally, can you look at the existing process? Are you augmenting it? Are you creating something new that's enhancing? Or is it something that you really need to retire and align those skills to the new process? So clash detection, design reviews, a really classic one where you still have these 2 very different talent pools, both with relevant experience, but they're doubling up their efforts. And even though they're both coming from the right place, they are causing friction on the projects. So the next part I wanted to cover is a bit of automation that scales. So automation, I guess, at a localized level is really just, we see this quite a lot where someone was able to do something on a job, saved a lot of time, pats on the back, a few beers. But it can't be taken to another project. It's very specific to that job. And so or that person leaves and that skill gets lost with them or whatever. So the automation in our industry tends to be these little internal snippets of excellence that then disappear. And then scalability is a part I really don't think we've broken yet, which is the ability to ramp up, these efforts and roll them out to accommodate the growth without necessarily including more and more human and energy input as you ramp up that skill. So we'll do a quick couple of examples of automation. So this is a really low-level example. This is a subway in Paris. The issue was we had to get this really complicated model to this ugly-looking model because that ugly-looking model feeds into the analysis tool, and that was able to achieve, then the engineer can look at it, submit the updated design. He's got hair stuff now. So we were able to create some scripts that basically looked at the level of detail, strip out the unimportant stuff, convert it to these meshes, and then we were able to start knocking out these values. We knocked out about 38 hours for someone to strip this down, another 16 for an engineer to review. And so you're talking about 50 hours, and you're like, okay, 50 hours, that's not too bad. But we were able to do this 10 times on this station, and we had 4 other stations. So on this particular thing, we were able to knock out somewhere around 400 hours of effort just in redesign. Another simple one, 2D to 3D, we had an architect who really likes drawing in 2D CAD, but we were still having a 3D deliverable. So we were able to let the the architect stay in his 2D land, suck this stuff across, wrap it around the envelope, and update the model. This is all timber elements. So again, by combining the tools, you're able to keep people in the zones that they're comfortable with, and sometimes the time constraints aren't going to allow him to learn this. But even more important than that, taking something that is quite complicated, but allowing them to work in these 2D flattened views that a lot of architects like to work in, but still delivering the output. One of the other ones, this was a job we did a couple of years ago. I think a few people have seen this. This is, we had a job, 4 towers. We had to build this big precast concrete yard out the back of this project. And one of the issues we had is we dedicated a lot of the site to this precast yard. So we whipped up something. This is Dynamo for those who haven't seen it. And this is the precast panels based on the different types. There was over 9,000 panels to be poured, 96 types I think it was. And so the red shows the uncured, green shows cured, ready to be lifted. And you can start to see how many gaps that they'd allowed, particularly for this job, on that site. So you can see there's a lot of effort there where we can go and optimize the site. So and this is actually all powered by that secret BIM tool called Excel that I think everyone really uses, the one true BIM tool that exists. So behind the scenes, there's nothing fancy going on. This is just, if statements and this sort of thing. But what it enabled us to do is, as you can see in the corner there, this is, as I said, 4 different towers going up. You really got that space back. So we're able to put a lot more rebar, we're able to move a lot more of the original site constraints there. And then again, you can see that the actual precast yard is now really fully loaded up. So we're able to move more and more of that just in time to those points, print all the drawings on a live basis too as that demand shifted, because the concrete trucks are really flaky over there. Couple of other things, genetic optimization. This is done by our structural bad monkey in Norway, Havard. So this is using genetic solvers to automatically optimize the structure. This is evolutionary solver if people haven't used it. This is Galapagos from Rhino. And similar things with lighting design. So again, this is taking existing lighting designs. If this one loads up, there we go. Existing lighting design, running this again through a genetic optimized solver and starting to actually update the lights based on the values that we were giving from the engineer in terms of their movement, and then pushing that stuff back through. And I've got a minute, and I did have 40 slides. So let's see, I can do it 58 seconds. Automation that scales. This is a project in France, Le Monde headquarters. The envelope was done in Rhino. We had to figure out how to create a randomized solution for this. So we're taking the Rhino models. We built these very specific templated components for the architect, and really came up with a solution that allowed us to apply the randomization, apply the rotations, and then roll it out across this job. And again, this is where the automation scales, because when you actually start to look at the size of the project and the facade, Due to the way that we built these, we were able to update this facade in about 45 seconds across 5 different countries. So again, when you take the right templated approach, you can really speed up the design. Previously, they were using some other tools that were taking 6 hours to do this per change. So when you're doing this exploratory stuff, it's really, really important. Penetration automation, again, real quick. Rather than just running a Navisworks clash detection going, oh, Craig, we've got clashes, we'll tell someone, we're able to take them and start going, okay, well, if it's clashing with a pipe, put a sleeve. If it's clashing with that, make sure you draw this type of penetration instead. So again, moving away from this dumb output of, oh, now we've got to tell everyone they need to cut holes in their slab. This started cutting the holes for them when it was appropriate, or putting in a sleeve, or just cutting a core hole if that was what was needed. So again, we can remove a lot of those decisions with a few rules. And then this was able to be marked up and tagged up, so we had a penetration layout for the builder as well. Very lastly, and I'll leave it there because I know I'm over time, is then things like generative components. It's the same one again. Is where you start, when you really think about scaffold, you're really just detailing edge protection. That one's a doctor's stunned, but he's got an onion on his head. I'm not kidding. And so this is about drawing the edge protection, defining the extents, and again, automatically generating that edges. So defining the rules, essentially, and the geometry is created from those basic rules. And so it allows, again, this connection between, you know, the temporary works guys who are more focused on the individual bits, but still able to get the quantity, still able to get the staging out of that work. So, so again, if you're not creating models, you really should be making sure your team has access to all this stuff, and then starting to look at how to automate these processes. So thank you.